Hi Quest Seniors, it's Joe Bailey here with a brief video to give you an example of what a preliminary results presentation might look like on November 14th. I thought I would go ahead and do this example based upon the example chapter in the book Quality Matters, and so you could see the names here of the team members who were all the teaching fellows from the Quest courses last year. So as it says in the book, we have a client, Banana Computer, and I'd like to just go ahead and take you through the presentation and see if this would give you a good example. I'll go once through. It should take about 4 or 5 minutes, and then I'll step back and just talk about the significance of each of the slides and why it belongs there. So thanks very much for being here today. I want to talk to you about a very exciting project that we've been working on this semester, which is to reduce the lead time variability at Banana Computer. So first, what is lead time variability? Defined, it's the variation of the time between the initiation and execution of a process. And what you can see here on the graph is a normal distribution, which actually shows the lead time variability experienced by Banana Computer for a lot of its orders and executions. So it expects to go ahead and receive products within a 14-day window, and sometimes it receives them early, that would be negative territory, or sometimes it receives it late, which is the positive territory. Now when products arrive early or late, it actually has a cost associated with Banana Computer. For every 1 day late, it costs Banana Computer $25,000, and for every 1 day early, it costs Banana Computer $5,000. So it's really important to go ahead and actually get the products exactly at that 2-week window. It's impossible to always get that 2-week window, but we can go ahead and reduce the variation in this distribution. In other words, we can go ahead and reduce the standard deviation of this graph. So our proposed solution is going to be that Banana Computer invests in package tracking technology. This is widely adopted by a number of different vendors within the industry and will allow for better information, real-time information within the supply chain, such that Banana Computer can coordinate its processes a little bit more and let their vendors know and their supply chain partners know how to go ahead and accelerate shipment of different products. While this technology is not cheap, it's going to cost Banana Computer approximately $1.5 million. Their approximate savings will be around $2 million of savings for every year that they implement. So you can see within the first year that they're going to go ahead and recover $500,000. And as you can see from this graph down below, that the variation that existed before is now greatly reduced and we get a much tighter normal distribution. So let us describe a little bit about how we came up with this proposed solution, because we as a team considered a number of other possible solutions as well. So we start with the context. Very important to understand who our client is. Know that they manage about 3,000 stock keeping units, or SKUs. They do 15 inventory turns per year, which means that every year that they can go ahead and expect 15 times their inventory being depleted and replenished. There's about $300 million in products actually being transported between the United States and China, and this is the retail value of the products that are being shipped between USA and China. And of course the coordination of their supply chain is very important. Because of the large number of inventory turns that Banana Computer has, that means that their warehouse is relatively small. Their products are also being received from multiple vendors and have to be assembled at the Banana Computer warehouse. And the variation that exists in the lead times, it really is a pain point for them. And as we heard previously, the dollars associated with products that are received too early or too late is a real issue. So the way in which we decided to help Banana Computer reduce the variation in lead times was through a combination of quantitative and qualitative approaches, putting some of those approaches into a development of a cause-effect model and developing some recommendations. So the first thing we did is we looked at the data that exists within the supply chain to understand the current state of Banana Computer, and then take a look at a regression to examine the different sources of variation. We then used those regression weights in combination with the qualitative data to interview some of the people within Banana Computer, and we actually also reached out to some interviews with their vendors, so not people within their company, but people who are actually helping manage the supply chain for Banana Computer. And this gave us a cause-effect model, allowed us to identify the different causes for variation in their supply chain or in lead times, and gave us some recommendations. So let's show you the cause-effect model, the final cause-effect model. So we can see here, this is what's called a fishbone diagram. And the problem that we identified here is lead time variation. And there's lots of different potential sources, including the materials, the environment, and the management. And there's going to be some secondary causes as well within each of these primary causes. After our analysis, we identified that the materials portion of the fishbone diagram or cause-effect model was the main cause or main lead to lead time variation. And it is therefore this portion that we want and looked at some possible recommendations. Initially, we came up with 15 possible recommendations based upon an examination of what other people have done, but we narrowed the list down to 3 based upon our discussions with Banana Computer. And our project champion was very helpful in identifying those possible solutions that fit best within the context. So the first one is that Banana Computer may manage its supply chain channel directly. Right now, they outsource the logistics to a third-party vendor, and they thought that perhaps they could do a better job managing it than the third party. The second one is they could actually change the production schedule so that it actually incorporated some of the variability within lead times. And what this would do is it wouldn't actually reduce the lead time variability, but it would reduce the cost of the lead time variability. And the third possible solution was that they would implement some type of tracking technology. And of course, this is the solution that we ultimately recommend that Banana Computer would implement. So let's describe a little bit more in depth what our solution entails. So we mentioned already that it would cost $1.5 million to implement a device such as the one that you see here in the picture, whereby different people within the warehouse would actually scan in products as they were received and as they were shipped from the various points. This data would then be shared not only with the different logistics providers that Banana Computer works with, but actually within the supply chain operations itself. And so therefore, if there was some variation in lead time, Banana Computer may use this information to do some other things, such as change their production schedule. But right now, this information is not available to them. The cost entails buying the equipment as well as training the employees and their vendors to go ahead and use the equipment, as well as integration with Banana Computer's current supply chain management software. So again, we're very excited about this possible solution for Banana Computer. When we shared this idea a few days ago with them, they were very excited about it. We're currently working with them to go ahead and flesh out some of the implementation details, and we look forward to sharing that with you in a few weeks at our final presentation. So again, we thank you very much. We want to thank our project champion as well as our faculty advisors and all the classmates out there. And now we'll open up for any questions. Okay, so you can see what I did here was to basically go through a presentation that looks a lot like a final presentation except for a few points. So the slide deck is pretty thin. You could see there's only 9 slides, and given the fact that you're going to have around 10 minutes to present, it's probably a good idea to go ahead and keep this at a very high level. The one exception where there was some depth was when I started talking about the implementation. And you can see when I talked about this that I was describing not only what our proposed solution was, but the fact that we're not yet done investigating all of the different aspects with the implementation plan. So again, that's one area where this would be a preliminary presentation as opposed to a final presentation. The next thing I want to focus on, I guess, is the fact that the proposed solution is here in slide number 3. Again, when you think about the audience for the preliminary results, some of them may be hearing your presentation for the first time. And it's very good to foreshadow what your proposed solution is going to be before you get into some of the depths. I have a graphic down here which looks at before and after, I think, which is a nice way to kind of visually show what's going on. Of course, if this were more accurate, to actually have some numbers associated with it, that would be better. A methodology slide is something I think that is important also to include in your presentation. We want to know the process by which you got to that recommendation. And if there are any flaws or challenges with your methodology, this would be a place where the audience can go ahead and maybe give some suggestions. I suspect that all of you at least have one aspect of this, maybe a quantitative aspect or a qualitative aspect, but you may not have both of them together. So I will say that for your preliminary presentations, I'm looking for a really strong methodology. Again, you're going to have to make objective recommendations to your client, and your audience is going to have to find this believable. If we don't find it believable before Thanksgiving, it's no big deal. We can go ahead and give you some suggestions on how to make it more convincing, but the methodology slide would be really good. There's some diagrams like a fishbone diagram. Again, this doesn't have all the data associated with it, but it's a nice way to provide a linkage between kind of what your analysis is and kind of how you got to your proposed solution. You'll notice that I added the kind of appearance of a red box to go ahead and get the people to focus on a particular thing. One thing I saw in your last presentation among some teams, not everybody, but there were some kind of charts that were kind of like an eye chart, where there'd be a very small font size and a lot of data, and you want to go ahead and see if you can go ahead and focus in your audience on a particular portion of it. And the appearance of a red box like this one, or even in the potential recommendations, where you can see kind of the appearance again of a red box or underlining, or for using Prezi, if you can zoom in a little bit, that might be a really nice way to do that. So again, I think overall, try to keep your slide deck pretty thin, try to get the dialogue going, try to keep it at a high level, but make sure you do dive in two main areas: the methodology area, as well as what your main recommendation is, and then allow for the questions and answers to go ahead and help do that. So, sorry this went a little bit longer than anticipated, but I hope this helps with your presentation next week. We look forward to meeting with you on Wednesday.